Hello, my name is Daniel Jin, and today we will be going through the AMC 10A from the year 2018, so let's get started. First problem, what is the value of this thing? Okay, so to do this, we will first do, this is 3, and 3 is the negative first power, that's 1 over 3, that plus 1 is 4 over 3, that inverted is 3 over 4, plus 1 is 7 over 4, 7 over 4 inverted is 4 over 7, 4 over 7 plus 1 equals 11 over 7, so the answer is B. Number 2, Lillian has 50% more soda than Jacqueline, and Alice has 25% more soda than Jacqueline. What is the relationship between the amounts of soda that Lillian and Alice have? Okay, so if Alice has 25% more than Jacqueline, then we have L, A, J for the 3 people. If Jacqueline has 4, then Alice would have 5, right? But then since Lillian has 50% more than Jacqueline, that means Lillian would have 6, right? And so the relationship between these two, 6 is 20% more than 5. So the answer is Lillian has 20% more soda than Alice. The answer is A. Number 3, a unit of blood expires after 10 factorial, which is this much seconds. Yazin donates a unit of blood at noon of January 1st. On what date does this unit of blood expire? Okay, so first, this is 10 times 9 times 8, 7, 6, 5, 4, 3, 2, and I won't do the 1 seconds, right? And then this for number of days. 60 seconds is a minute, 60 minutes is an hour, and 24 hours is 1 day. So if we do that, we get 60 crossed out, and then 60 crossed out 24 crossed out like that. And then we'll cross 24, and then we'll cross out the remaining 60 by this. Gives us 12 remaining, and then this gives us 4 remaining, this gives us 2 remaining. So this is 3 times 2 times 7 equals 42 days, right? And so this unit of blood will last for 42 days. And Yazin donates a noon of January 1st, so Yazin, yeah, so 42 days, this equals 31 days plus 11 days, so 1 month and 11 more days would go before the unit of blood would expire, right? So first, when after 31 days have passed, that will be February 1st, right? Because January has 31 days, and plus 11 more days means this is February 12th. So the answer is E. Number 4, how many ways can a student schedule 3 mathematics courses, algebra, geometry, and number theory in a 6-period day if no 2 mathematics courses can be taken in consecutive periods, and the other courses that the student takes are of no concern here? Okay, so we first have 3 math courses, right? And they can't be taken in consecutive periods, so we will have something between them. And we have total 6 periods, right? And so to do that, we have 5 periods already, and so we need to decide where the 6th period will go. That can go either here, 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 or here. Okay, so it has 4 choices, right? 4 times, and then the other choices are of the other courses are of no concern. But then these 3 math courses, they are all different, and they do matter, right? And so that would just be 3 factorial, because what will come here, what would come here is 3 times 2 times 1. So this is 4 times 6, which is 24. The answer is E. Number 5, Alice, Bob, and Charlie were on a hike and were wondering how far away the nearest town was. When Alice said, "We are at least 6 miles away," Bob replied, "We are at most 5 miles away." Charlie then remarked, "Actually, the nearest town is at most 4 miles away." It turned out that none of the 3 statements were true. And so let D be the distance in miles to the nearest town. Which of the following intervals are the set of all possible values of D? Okay, so let's say Alice, Bob, and Charlie were here, and Alice said we are at least 6 miles away. So here this is 0, then that would be 6 over there. Bob said we are at most 5 miles away, and Charlie said that it's at most 4 miles away, so it's like this. And they're all wrong, right? So the actual nearest town will be somewhere between here and here, right? So it's between 5 and 6, it's 5,6, it's D. Number 6, Sangho uploaded a video to a website where viewers can vote that they like or dislike a video. Each video begins with a score of 0, and the score increases by 1 for each like vote and decreases by 1 for each dislike vote. At one point, Sangho saw that his video had a score of 90, and the 65% of the votes cast on his video were like votes. How many votes have been cast on Sangho's video at that point? Okay, so if 65% of the votes were like votes, that means the rest, which is 35%, were dislike votes, right? And the score decreases by 1 for each dislike vote. That means 65 minus 35, which is 30% of the of all the votes, were score of 90. So they contributed to the score of 90, right? 90, yes, that's the score of 90, right? And so how many votes have been cast on Sang-ho's video at that point? So 10% of the votes would be 90 divided by 3, which is 30, and so 100% would be 30 times 30 times 10, right? So that would be 300. So the answer is 300 votes. The answer is B. Number 7, for how many not necessarily positive integer values of n is the value of this an integer? Okay, so to do this, first we will dissect 4,000. 4,000 equals 2 to the 5th power times, 2 to the 5th power times 5 to the 3rd power, right? And then this times 2 over 5 to the nth power. But then they don't have to be positive, right? So if we were trying to get rid of the 2's here, right, then n can be -1, -2, -3, -4, or -5, up to -5, right? Because after that, then it would not be an integer. And if we were trying to get rid of the 5's, then n could be 1, 2, or 3. But then we have our last choice, which is where n is 0, and then that would also be an integer because that would just make it 4,000, right? And so we have 5 here, 3 here, 1 here. That gives us 9 total. The answer is E. Number 8, Joe has a collection of 23 coins consisting of 5-cent coins, 10-cent coins, and 25-cent coins. He has 3 more 10-cent coins than 5-cent coins, and the total value of his collection is 320 cents. How many more 25-cent coins does Joe have than 5-cent coins? Okay, so Joe has 5-cent coins, 10-cent coins, and 25-cent coins. Let's say he has A 5-cent coins, then he has 3 more 10-cent coins than 5-cent coins, so this would be 3 plus A, and it's total 23 coins. So 25 would be 20 minus 2A because the sum of all this would have to be 23, right? And the total value is 320 cents, right? So the total value is 320 cents. So 5A plus 10 times 3 plus A plus 25 times 20 minus 2A equals 320. So A plus 2 times 3 plus A, which is 6 plus 2A, plus 5 times 20 plus 2A, which is 100, minus 10A, right? This equals 320 divided by 5, which is 64, right? And so this will give us 106 minus 7A equals 64, and if this goes there, if this goes over there, that would give us that 106 minus 64, which is 42, equals 7A, so A equals 6. How many more 25-cent coins does Joe have than 5-cent coins? Okay, so 25-cent coins, this is 20 minus 2 times 6, which is 20 minus 12, this equals 8. And this is just 6, right? So 8 minus 6, the answer is 2. It's C. Number 9, all of the triangles in the diagram below are similar to isosceles triangle ABC, in which AB equals AC. Each of the 7 smallest triangles has area 1, and triangle ABC has area 40. What is the area of trapezoid DBCE? Right, so we want the area of this trapezoid right here. So what we have to do is get the whole area and subtract ADE from there, right? But then we have the area of ABC, which is 40, so we just need to get to this area and subtract it, right? But then since this is each of the 7 smallest triangles, and since these are so all of the triangles are similar to ABC, right? That means this one and this one is also similar. But then this length and this length ratio is 3 to 4, right? That means this to this ratio is 3 to 4. Same thing for here, 3 to 4, right? That means the ratio of the areas is 9 for this one and 16 for the big one, right? So this area would be 16 ratio, right? So the difference, which is this one here, that will be 16 minus 9, which is 7. And since each of the 7 smallest triangles has area 1, the actual area of these is actually 7, right? And so that means that this whole area of ADE, that must be 16, right? And so DBCE, this is ABC minus ADE. ABC is 40, minus AD is 16, this is 24. The answer is E. Number 10, suppose that real number x satisfies this. What is the value of this? Okay, so since this is a plus and this is minus, what then obviously we want to multiply those two together, right? And so if we do multiply them, that will give us 49 minus x squared minus 25 plus x squared. This equals 49 minus 25 equals 24, right? This is, let's call this a. That would equal 3 times a. And so 24 equals 3a, a equals 8. We want a, right? So it's 8, the answer is a. Number 11. When 7 fair standard 6-sided dice are thrown, the probability that the sum of the numbers on the top faces is 10 can be written as n over 6 to the 7th power, where n is a positive integer. What is n? Okay, so since the sum of the numbers of the top faces have to be 10, but then 7 are thrown, right? So since the lowest number that each dice can get is 1, so we have at least 7, right? And we need to add 3 more here, but then we don't know where to add those remaining 3, right? So we have 3 possibilities. We can add 3 like this to be like 2, 2, 2, 1, 1, 1, 1. Or we can add it like this, right? To make it 3, 2, 1, 1, 1, 1, 1. Or we can just add 1, 3. So to make it 4 and all the others 1. And so for just adding 1, 1, 1, this would give it 7 choose 3, right? Because we have to choose where of the 7 to put to these 3 ones, right? And for 2 1s, this is 7 times 6, because first we choose from 7 where to put the 2, and next we choose from the remaining 6 where to put the 1. So that's 7 times 6, and then this is just 7, because we are wondering where should we put the 3, right, of these 7. And so 7 choose 3, this is 7 times 6 times 5 over 6, this is 35. And then these two added together is 7 times 7, which is 49. So 35 plus 49, that is 84. The answer is E. Number 12. How many ordered pairs of real numbers x, y satisfy the following system of equations? This one and this one. Right, so we know this one, so let's get about graphing this one. Here, since it doesn't matter if x or y is positive or negative, that means it is symmetrical for the x-axis and the y-axis, right? And so let's just see what if x and y is greater than 0. X is greater than 0 and y is greater than or equal to 0, right? And so these would divide into 2, right? If x is greater than y, or if x is less than y. And so if x is greater than y, then this would be positive. So x minus y equals 1. Y equals x minus 1. And for this one, y would equal negative x plus 1, right? No, sorry, y would equal plus x minus 1. No, plus x plus 1, right? And so we would have a graph that looks something like this, right? Because y is x plus 1 is right here, and y is x minus 1 is right here, right? And since this is symmetrical to the x and the y-axis, then erasing these, we would have something like this would be mirrored on this side, like that, and also on this side, like that, and also on this side, like that, right? So this would be 1, and this would be 1, this would be negative 1, and this would be negative 1, right? And then we have x plus 3y equals 3, which is y equals negative 1 over 3 x plus 1. So this is like that, right? So this is what x plus 3y equals 3 would look like. And then how many ordered pairs satisfy both of these? So we need to find the intersection points. And we have 1, 2, 3 intersection points. That the answer is 3, it's C. Number 13, a paper triangle with sides of length 3, 4, and 5 inches as shown is folded so that point A falls on point B. What is the length in inches of the crease? Okay, so it's folded like this, so like that, right? And so if we draw a line from B to whatever point that looks like it's going to be folded on AC, and then we put a line like that, that would be 90 degrees, right? And so this and this would be the same, and these two would be the same, and we want the length of the crease, so we want this length, right? And so this is, the whole thing is 5, half this is 5 over 2, so this is 2.5. And since the ratio of ABC is equal to this ratio, right? And so this over this is this over this, which is 4 over 3. And so 2.5 over, let's call this x, over x equals 4 over 3. So 4x equals 2.5 times 3. X equals 5 over 2. 5 over 2 because that's 2.5 times 3 times 1 over 4. This equals 15 over 8. The answer is D. Number 14. What is the greatest integer less than or equal to this? Right? Okay, so for this one, first it's 3 to the 100th power, 96th power, right? So these are some incredibly large numbers, and so this means that they are like basically very close to very close to infinity, and since the bases are different, that means the results to the 100th power and the 96th power, they are drastically different, right? And so 3 to the 96th power and 3 to the 100th power is so much more large than 2 to the 100th power or 96th power that it makes it seem like they are very small in comparison, right? And so this value is actually going to be very similar to just this value, 3 to the 100th over 3 to the 96th power, right? So this is very similar to 300th over 3 to the 96th power equals 81, right? Because it's 3 to the 4th power, and so it's very close to that. So it's either A or B, and it won't be either C, D, or E, right? But then one other thing is these do have an influence, right? So it's not exactly equal to 81, and since this is at the denominator, that means that it's going to put this value down somewhat, right? Because this isn't dividing by just 3 to the 96 power, but this thing, right? So that does have an impact. So it lowers the value a little. So it's slightly lower than 81, right? So this means it's 80 point something. So the greatest integer less than or equal to this is 80. The answer is A. Number 15. Two circles of radius 5 are externally tangent to each other and are internally tangent to a circle of radius 13 at points A and B as shown in the diagram. The distance AB can be written in the form m over n, where m and n are relatively prime positive integers. What is m plus n? Okay, so we have two circles of radius 5. So we have the midpoint here, and we will draw radii to B and to A. Yeah, so this is radius 13, and if we have the midpoints, so the the centers of the triangles, that means that this much is 5 and this much is 13, right? So this will be 5 and this will be 13 minus 5, which is 8, right? And same thing for here, this is 8 and this is 5. And so we want the distance A to B, right? So we want AB, so that would be from here to there, and we know this length, right? Because they're the sum of two radii, so that would be 10, right? But then the distance, yeah, so we know that this triangle and this bigger triangle, they are similar, right? And so we can use this ratio to figure out this ratio. And so since this is 10, that means 10 over 8 equals AB over 13, right? So this is AB over 13. And so AB equals 10 over 8 times 13, which is 130 over 8. This is 13 times 5, that is 65 over 4. So 65 over 4, 65 plus 4 equals 69. The answer is D. Number 16. Right triangle ABC has leg lengths AB equals 20 and BC equals 21. Including AB and BC, how many line segments with integer length can be drawn from vertex B to a point on hypotenuse AC? Okay, so we have a right triangle called ABC, and it will look something like this. Right? And AB would equal 20. Okay, so the lengths are kind of off here. So let's say that this is AB and this is BC. This would be 20 and this would be 21. And including AB and BC, how many line segments with integer length can be drawn from B to a point on AC? Okay, so we need to find out the shortest length from B to hypotenuse AC, right? Because that way, we can look at the integers from this number to this length, and from this length to this length, right? And so if we do that, AC, we have to get AC first, right? So AC equals, by the Pythagorean theorem, this is actually one of the Pythagorean triples. So AC equals 29. So this much is 29, and so let's call this point D, right? And so BD would equal 20 times 21 over 29, because as you can see, this times this equals 2 times ABC, and this times this equals also 2 times triangle ABC, right? So their areas are equal. So this equals AB times BC over AC, right? That's what I've used here. And so this would equal 420 over 29, and this is something like 14. This is like 14 point something something something, right? And so this will be 14 point something something, and so that means all the lines like this from here to here, that those lengths would be from 15 to 20, including both of them. And same thing for here, it will be 15 to 21, including both 15 and 21, right? So for this one, we have 15, 16, 17, 18, 19, 20. That will be 6. And so we have 6 plus, and then this is just one more. So 7 equals 13. The answer is 13. It's D. Number 17, let S be a set of 6 integers taken from 1 to 12 with the property that if A and B are elements of S with A is less than B, then B is not a multiple of A. Where's the least possible value of an element in S? Okay, so so this set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And so obviously the least value can't be 1, because then because everything is a multiple of 1, right? And so 1 can't be it. What if 2 is the least possible value? So we would have 2, and then 3 would be there, 4 can't be there, 5 can be there, 6 can't be there, 7 can be there, 9 can't be there because of 3, 10 can't be there, 11 can be there, and that's it, right? So that's just 5. So that one fails. So 2 doesn't work, and so 2 doesn't work. What about 3? That would give it 3 would be there, and 4 will be there, 5 will be there, 6 cannot be there, 7 can be there, 8 cannot be there because of 4, 9 cannot be there because of 3, 10 cannot be there because of 5, and 11 can be there, and that's it, right? So 3 also is not possible. And so what about 4? What if it's 4? Then we can have 4, and 5 is possible, 6 is possible, 7 is possible, 8 is not possible because of 4, 9 is possible, 10 is not possible because of 5, and 11 is possible, and that makes 6 integers, right? So 4 is possible. The answer is 4. It's C. Number 18, how many non-negative integers can be written in this form, where ai is negative 1 or 0 or 1, for I is 0 to 7? Okay, so our least value will be 0, because this has to be non-negative, and so this would all and so that would be if all the A's are 0, so this is 0, 0, 0, 0, 0, 0, 0, 0. So that would make the whole thing 0, right? But then our greatest value would be when all these are 1, right? So it would be something like, no, let's start from here. 3 to the 7th power plus 3, 6, 3, 5, 3 to the 4th power, 3 to the 3rd power, 3 second, 3, 1 plus 3, 0. And let's calculate this. This would equal, this is 1, plus this is 3, plus this is 9, this is 27, this is 81, this is 243, This is 729, and 3 to the 7th power, that one is 729 times 3, which is 2187. And so if we add all of these up, that would be 10 plus 10 plus 30, and then plus 810, and then plus 2430, right? So this equals 40 plus 810 plus 2430, and so this equals 850 plus 2430, and this equals 3280. So we have so the greatest value is 3280, and the least value is 0, and we know that all of the values between 0 and 3280 are possible, because this is just like a base 3 number, with like -1 acting as the 2, right? And so this is just equal to a base 3 number. So every value between 0 and 3280 is possible. Therefore, we do 3280 plus 1 for the 0. So that's 3281. The answer is D. Number 19, a number m is randomly selected from the set 11, 13, 15, 17, 19, and a number n is randomly selected from this. What is the probability that m to the nth power has a unit digit of 1? Okay, so we have a number m from here, and it has to be m to the nth power, right? And note that this is a group of 20 integers, right? 20 integers. That means it's a multiple of 4, right? And so that will be important later on. Okay, so if we see, we have 11, 13, 15, 17, 19, and 11, 13, 15, 17, 19, and yes, and if we keep taking the powers of these numbers, then since we are only looking at the unit digit, then let's just try to see the pattern for the unit digit of the powers of these numbers, right? So for 11, it's always 1, right? Because 1 times 1 is always 1, so this will be always. So this is all the time, so that would be 1. And for 13, that would be 3, and then 9, and then 27, and then 81, and then back to 3, right? So this is 1 over 4. So the unit digit is 1 fourth of the time. And for 15, this is just 5 times 5 times 5, so it's always 5. So this is so the unit digit is 0 none of the time. And for 17, this is 7 times 7. First is 7, and then we have 9, and then 3, and then 1, right? And so also same thing, one of these 4 times is a unit digit of 1, and this is cycling, so that also gives us 1 over 4, very similar to 13, right? And for 19, 19, it's 9, and then we have 81, and then we have 9 again, and then we have 1, and so 9, 1, those two are keep repeating, right? And so 1 comes up 1/2 of the time, so it's 1 over 2. And so since this is 20 integers, and 20 is a multiple of 4, as I've mentioned before, that means that means that a number n randomly selected from 20 integers, that has the same probability as when it is selected from 5 integers, right? And so the probability that m to the nth power has a unit digit of 1, this is all over 5, and then we add all of these up. So 1 plus 1 over 4 plus 0 plus 1 over 4 plus 1 over 2, this is 2 over 5, so the answer is E. Number 20, a scanning code consists of a 7x7 grid of squares with some of its squares colored black and the rest colored white. There must be at least one square of each color in this grid of 49 squares. A scanning code is called symmetric if its look does not change when the entire square is rotated by a multiple of 90 degrees clockwise around its center, nor when it is reflected across a line joining opposite corners of a line, or a line joining midpoints of opposite sides. What is the total number of possible symmetric scanning codes? Okay, so let's input a 7 by 7 grid of squares like this. And so this will be our grid like that, right? And so it is symmetric. Sorry, if its look does not change when the entire square is rotated by a multiple of 90 degrees clockwise, or when it is reflected. Okay, so that is basically saying that we only have freedom for these squares, right? Because the rest of the squares, they are determined by like reflecting this shape, or by like rotating it, right? Like that, right? And so that will just make up the whole thing. And so this much is where we have freedom to put in black or white, right? So what's the total number of possible symmetric scanning codes? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 blocks, and we have 2 choices for each block, right? So it's 2 to the 10th power, but then we have to subtract 2 because it can't know all white and know all black, right? And so that would just give us this is 1024 minus 2. This is 1022. So the answer is B. Problem number 21. Which of the following describes the set of values of A for which the curves x squared plus y squared equals a squared and y equals x squared minus a in the real xy plane intersect at exactly 3 points? Okay, so x squared, yeah, so first of all, x squared plus y squared plus a squared, this would be a circle of radius a. And y equals x squared minus a, that would be a parabola with the y-intercept negative a, right? And so if we draw that, that would be like this, so like this, right? And here this would be negative a, and the curves would be intersecting there, right? And this would be a, and the a when they are intersecting, and when they are intersecting at only one point, and that is this point, right? And so if they are intersecting at more than one point, that would be like this, right? And so here they will be intersecting at this point, and at this point, so that will be 3 points, right? And if you see, all a values that are greater than this radius value would all be like this, would all have 3 intersection points, right? And so what we have to do now is we have to look at what radius value would make this only have 1 intersection point, right? And so since we're looking at intersection points, we will just combine those two. X squared plus y squared equals a squared, but x squared equals y plus a, so y squared plus y plus, so if we plug this x squared into here, then that will give us y squared plus y plus a equals a squared, right? So y squared plus y plus a minus a squared equals 0. So this will be our y values. And so if we solve for this, we're going to get an a value of 1/2, right? And so all a values that are greater than 1/2 will be like this. We'll have exactly 3 points. We'll have exactly 3 intersection points, right? And so our set of values for a would be that a is greater than 1/2, and so that is E. The answer is E. Problem number 22. Let a, b, c, and d be positive integers such that GCD of a and b equals 24, GCD of b and c equals 36, GCD of c and d equals 54, and GCD of d and a is between 70 and 100. Which of the following must be a divisor of a? Okay, so let's write out a, b, and c, a, b, and c, right? And so the GCD is 24, so a and b must both have 2 cubed and 3, and 2 cubed and 3, and b and c GCD is 36, right? And b and c is 36, which is 2 cubed times, which is actually 2 squared times 3 squared, so this should be 2 squared and then 3 squared, therefore this must also have 3 squared. C and D is 54, which is 6 times 9, which is 2 times 3 to the third power. 3 to the third power, so this should also, so C should also have 3 to the third power, right? And GCD of D and A, so D and A, this is 2 times 3 times any non-2 or 3 divisible number, right? And so this is between 70 and 100, and so 70 and then 6 times this number, and then 100, right? So if we divide by 6, then this number would be between 70 over 6 and 100 over 6, and 100 over 6, that is 16, yeah, that is 16 and 2 over 3, and 70 over 6, that is 11 and 2 over 3, and so the only value that is between 11 and 2 over 3 and 16 and 2 over 3, that would be 13, so the answer is D. Number 23, farmer Pythagoras has a field in the shape of a right triangle. The right triangle's legs have length 3 and 4 units. In the corner where those sides meet at a right angle, he leaves a small unplanted square S, so that from the air it looks like the right angle symbol. Very Pythagoras-y. The rest of the field is planted. The shortest distance from S to the hypotenuse is 2 units. What fraction of the field is planted? Okay, so the field is in this right triangle shape, and this much is 3, and this much is 4. That means this much is 5, right? So that's 5, and we will have to draw some lines. So those would be our lines, and then if we draw some more lines, then this would also be a right triangle like that, and this one here, this one at the edge, this would also be a right triangle, right? And so if we say that the unplanted fraction, so this is length A and A, that means this length is also A and this length is also A, right? But then since the whole ratio is the same, that means 3 to 4 to 5, that also holds true for these also smaller right triangles, right? And so that way this length must be A times 3 over 4, so this is 3A over 4, right? 3A over 4, and then this length would be 4A over 3, right? Since this whole length is 3, then we can find out this middle length, right? And so this middle length, that much is 3 minus A minus 3A over 4, so 7A over 4, and this much length, that is 4 minus 7A over 3, right? And so now we have to look at this right triangle. Yeah, so this right triangle, this also has the same ratios, right? And so 3 minus 7A 3 minus 7A over 4, this is, so this one is also a right triangle, right? So this length is 5 over 4 times 2, so this is 2 over 5, no, so this is 5 over 2, right? And so 7A over 4, this would equal 1 over 2, and so 7A equals 2, A equals 2 over 7, and so what fraction of the field is planted? So this is 3 and this is 4, so the whole field, this is, what is it, 6, right? And unplanted, this is 2 over 7 squared, which is 4 over 49. So the planted fraction, that would be 6 minus 4 over 49 over 6. And so this is 6 times 49, all under, and then we have 49 times 6 minus 4. And so 49 times 6, that is 294, so it's 294 over, no, and that under 294 minus 4. And if we divide by 2, if we divide everything by 2, that gives us 147 under 147 minus 2. So 147 minus 2 is 145. So 145. So that would give us an answer of 145 over 147, which is D. Problem number 24. Triangle ABC with AB equals 50 and AC equals 10 has area 120. Let D be the midpoint of AB and let E be the midpoint of AC. The angle bisector of angle BAC intersects DE and BC at FNG respectively. What is the area of quadrilateral FDBG? Okay, so this would be our diagram, and so AB, this is 50, and AC, this is 10. It isn't exactly to scale, but it doesn't really matter. And it asks, what is the area of quadrilateral FDBG? So this much, right? And so this is an angle bisector, right? And this is 50 to 10, right? So that means BG to GC, the ratio of the length is 5 to 1, right? And since the ratio of the length is 5 to 1, but the height is the same, that means these two triangles, so the ratio of their areas is also 5 to 1, right? And so if the whole thing has area 120, then that means this would have area 20, and this would have area of 100, right? So ABG area 100, right? And then it asked for the area of FDBG, so this length, right? But then if you see, FDBG is 3 over 4 times ABG, right? Because if we just divide ABG like this, so parallel like that and like that and like that, right? Then that gives us that this area is 3 over 4 of the whole thing, right? So 3 over 4 times ABG, this is 3 over 4 times 100, this is 75, so the answer is D. Last problem, problem number 25. For a positive integer n and non-zero digits a, b, and c, let a and b the n-digit integer, each of whose digits is equal to a. Let b and b the n-digit integer, each of whose digits is equal to b, and let c and b the two n-digit, not n-digit integer, each of whose digits is equal to c. What is the greatest possible value of a plus b plus c for which there are at least two values of n such that cn minus bn equals a squared n? Okay, so for better visualization, let's just say that n is equal to 3, right? So if n is equal to 3, then cn is 2 n-digit, right? So it's c minus b. This is equal to a squared, right? And so this is c times 111 minus b times 111 equals a squared times 111 times 111, right? And so if we divide 111 from everything, then that will give us c times 1001 minus b equals a squared times 111, right? And so let's look for values of a, b, and c for which this is true. And so c times 1001 is going to be awfully close to c times 1000, right? And so a squared times 111, that would have to be close to some thousand value, right? And so the best way would be for a to be 3, so that 3 squared would be 999, right? And so a can be 3, and if a is 3, this is 999, and b has to be a digit, right? And so b has to be less than 9, and so c should be 1, because that's the only way for b to be less than 10. C equals 1, and if that happens, b is 2, because 1001 minus 2 is 999, right? So b would equal 2, and this is not the only way for this to happen, because if a was 6, right, then that would be 36. This would give 9 values, so that's 3996, right? And so because this is nearly 4000, that means c should be 4. So if a is 6, then c can be 4, right? So it's 4004 minus 3996, b would equal 8. And if we search for any other values of a that would make a and b and c all like integers that are less than 10, then there's none, right? And so these two are the only two possible ways. And what's the greatest value of a plus b plus c for which there are at least two values of n, right? And so we need the greatest possible value of a plus b plus c, and if we add these, this gives us 6. And for this gives us 18. So the greatest value is 18. The answer is D. So that was it for the AMC 10A for the year 2018, and thank you for watching.